Hello students, today let us see a problem in equivalence laws in the subject discrete mathematics. Let me first explain the problem. We are given a statement formula, a lengthy statement formula like this, and we are asked to prove that it is a tautology. Very particular about this question that we should not use truth table, that is we have to use only equivalence laws to prove it is a tautology. First of all, what is a tautology? The statement formula must be true irrespective of the values taken by the variables in the statement formula. So we have to prove this is equivalent to the truth value t, that is what we are supposed to prove. So first of all, let me start with the given statement formula as it is. Now I consider this as a first term, this as a second term, this as a third term, this as a fourth term. Let me concentrate on the second term first in this next step. So in the next step, negation is outside this bracket. So let me bring that negation inside the bracket. Bringing negation inside the bracket is guaranteed using De Morgan's law. So what does the De Morgan's law state? When we bring that negation inside the bracket, the connectives will exchange. And connective will become R connective will become AND connective. Moreover, if there is already a negation appears in front of the variable, that negation will disappear. If there is no negation in front of the variable, negation will adjoin, will accompany. That is the De Morgan's law. So already there is a negation. So when I bring that negation inside the bracket by double negation law, that negation will disappear. Already there is a negation in front of Q. When I bring that negation will disappear by double negation. When I bring negation inside the bracket, that will disappear and I will get only simply R. And similarly, AND connective will become R connective will become AND connective. This is by De Morgan's law. This term is kept undisturbed. And let me combine the third and fourth term. Look at the third and fourth term. Inside the bracket we are having AND connective. Outside the bracket we are having R connective. For this type of connectives, inside the bracket AND connective, outside the bracket R connective. So when we are having different connectives inside and outside the bracket, we should apply distributive law. How we are going to apply distributive law? Look at that. In both the brackets we are having negation P in common. So let me take negation P outside. When we take negation P outside, that outside connective will come inside and inside connective will come outside the bracket. So outside connective R connective will come in between negation Q and negation R, and the AND connective inside connective will come outside the bracket. This is how we are applying the distributive law. Now I take this term as first term and this term as second term and this term as the third term. Now second term I am going to simplify. Second term, which law we shall apply? Inside the bracket we are having AND connective, outside the bracket we are having R connective. So in this case we shall apply distributive law. How we are going to apply distributive law? Just like multiplying P inside the bracket. When we multiply P inside the bracket, what we have? P into Q plus P into R, like that we are having. So PRQ and PRR. This is how we are going to apply distributive law in the next step. What happens to the third term in this step? So negation appears everywhere. So let me take negation outside. So that is guaranteed by De Morgan's law. When I take negation outside, that negation will disappear from each term, and when I take negation in common, that connectives will exchange. AND connective will become R connective will become AND connective. This is by De Morgan's law. Now in this step I take this as first term, this as second term and this as third term. Now how we are going to simplify? Look at that. I am going to simplify first term, second term and third term. Look at the connectives. Inside the bracket AND connective, outside the bracket and connective. When we have same connective inside and outside the brackets, we shall apply associative law. So in associative law, what does we do? We just change the bracket. So with the second term and third term, we are having bracket. Now it is going to be displaced. So for the first term and second term, dislocated for the first term and second term. So PRQ and PRQ and PRR. Now this term is kept undisturbed. Look at this term, first term, second term, third term. How we are going to simplify? I am going to apply idempotent law. Look at the first and second term, they are one and the same. So what does the idempotent law state? When your term is repeated, when your variable is repeated more number of times, it may be considered only once. That is the idempotent law. So PRQ and PRQ is applied and considered only one time, and this PRR is taken as it is, and this term is taken as it is in the next term. So for the first and second term, I applied the idempotent law. Now look at here, I take this as first term, this as second term. Look at the connectives. Inside the bracket we are having R connective, outside the bracket we are having AND connective. So what we shall do, when we are having different connectives inside and outside bracket, we shall apply distributive law. How we are going to apply distributive law? Look at that. P is common in both the brackets, so let me take it outside. So when I take it in common, the outside connective will come inside and inside connective will come outside. P, R, Q and R I will have. Okay, so this step is arrived. Now for the next step, you take this entire term as the first term and this entire term as the second term. Look at that. It looks like P, R, negation P. So by complement law, P, R, negation P shall be replaced by T. So the final answer, it's a truth value T. So the given statement is a tautology we shall conclude. So next video, let us see another problem. Thank you.